Welcome to the wonderful world of astronomy. We're in chapter 3 on the science of astronomy. We're looking in this chapter at the foundations of astronomy going back to ancient times, and it's related to the foundations of modern science. So in this chapter, we're also looking at what exactly science is and the philosophy of science. And in this video, we're going to look at ancient astronomy. The ancient roots of science and astronomy. Astronomy goes back many thousands of years. Originally, it wasn't a scientific pursuit, but it was used for navigation and survival. So thousands of years ago, people realized that these lights in the sky that we know of as stars, that they are in predictable fixed patterns night after night, year after year, and they could be used kind of like landmarks to find your way around, but they are sky marks, so people could use them for navigation. They could also be used as a calendar because people realized that certain stars, certain constellations always come up at the same time at given times of the year. And in fact, our calendar is based on what people in ancient times thought about the stars, what they did with the stars. Our measurements of time are all related to astronomy. So our concept of the year, our concept of seasons, of days and months, these all go back to, they have something to do with astronomical phenomena. Ancient people of Central Africa learned that they could predict the seasons and think about the rainy seasons from the orientation of the crescent moon. So if you look at this picture, and again, if you look at the bottom, it says January, February, March, April, May. Now keep in mind, those are more modern conventions. In ancient times, they didn't have concepts of January, February, March, April, May. That came later after people had developed the calendar based on the stars. But let's look at this. The crescent moon in Central Africa, this is somewhere near the equator, they notice that when it is a crescent, it's at slightly different angles. So here you can see right here in the middle of the chart, it's tilted at 0 degrees. And then going from June in the middle of the chart, it tilts to the left slightly. It has a maximum tilt in October, and then it starts tilting back to the right. We have December, and now go back to January, it's tilting more and more to the right. It has a maximum tilt in March, and then it starts tilting back to the left. So the moon would do this seesaw tilting back and forth. And they realized that they got more rain centering on the time in the year when the moon wasn't tilted at all. That's when they got the most rain. So the rainy season was about 3 months before that and 3 months after that. So they were using the moon, the orientation of the moon, as a calendar to predict rainfall. The days of the week that we use are named after the 7 wanderers in the sky. Now, in ancient times, the Greeks, they recognized that the stars are all fixed in the sky, but there are 7 objects in the sky called planetes. We get the word planet from that, and it means wanderers. So they took these 7 wanderers in the sky, and they are what we now know of as the sun, the moon, and the planets that are visible without a telescope, because those are the only ones they could see. So Mercury, Venus, Mars, Jupiter, and Saturn. And they named a day after each one of them. Now, depending on what language you're speaking, these are all European languages, but sometimes it was taken from the Latin version or the Roman version of the Wanderer in the Sky, sometimes the Germanic version. So let's look at this. Let's start with what Sunday is named after. It's named after the sun. So in English, it's the day belonging to the sun. Monday is the day belonging to the moon. And you go over to Spanish, lunes, and so that reminds us of the Latin word for luna, which is moon. And so it's the day named for the moon. The next day is named after Mars. Now, in the Roman languages, so this would be French and Spanish and Italian, it is something that sounds like Mars's day, the day for Mars. And in Spanish, Martes, in French, Mardi. English is not a Latin language or a Romance language, it's a Germanic language. So the English days of the week are actually named after the gods in the mythology of the northern part of Europe, and these would be the Germanic gods. So they didn't have Mars, but their god of war was Tu, and so it's in English Tuesday, the day belonging to Tu. Mercury, so the day belonging to Mercury, in Spanish, it's miércoles, sounds kind of like Mercury. In the northern part of Europe, where they didn't speak Latin, they spoke more Germanic languages, they had the god Woden, otherwise known as Odin, and so that day was Woden's day, and here we have Wednesday. Jupiter, now in Latin, Jupiter had a nickname, and it's Jove, and so from that we get in Spanish Jueves. But in the northern part of Europe, they had the god Thor, and so Thor's day, Thursday. Venus in Spanish is Viernes, and in the Germanic languages, in that mythology, the goddess's name was Freya, and so Freya's day became Friday. And then Saturn, we have Saturn's day became Saturday. So the main point here is that the 7 days of the week were each in the European languages, whether the northern part where they spoke Germanic languages or in the southern part where they spoke Romance languages. The 7 days of the week are named after what they named, according to their mythologies, the 7 wanderers in the sky. In ancient Egypt, they use obelisks. Shadows could tell the time of day and the season. So here's an obelisk you can see with a bunch of people around, so a very tall tower. And you notice it's casting a shadow, so the sun is obviously on the other side. And the length of the shadow can show what time of day it is, but the orientation of the shadow will show what season it is, because as the sun is, let's say, to the east, let's say the sun is rising right now in this picture, then the sun has a more northerly, it's more in the north, and so its shadow goes more to the south in the summer. But as the year goes on, as winter approaches, the sun takes a more southerly course, so maybe the sun is over where my marker is, and in the winter, the sun's shadow will be going this way, more to the north. So where it's pointing can tell the season. And here are a few other obelisks all around where the Egyptians had domain in ancient times. There are many, many of these obelisks. And this reminds me of on The Simpsons many years ago, the drunks in the bar, they weren't allowed to serve alcohol until 5 p.m. And so they were hunched over in the corner of the bar where a little bit of sunlight came through, and they were noticing that as the sun moved, as the sun set towards the end of the day, once the sun's the sun light goes to this line, they knew it was 5 p.m. drinking time. And this is really based on ancient conventions of how people used the shadow of the sun or where the sun falls to tell what time of day it is. In Britain, here you have the inset at the upper right, a map, and there's Stonehenge right there. Stonehenge was built over a period of more than 1,000 years. It wasn't continuously built. It was built in stages. So they would build a bit, 1 century, take a break for a few centuries, come back and build a bit more. And it began building around the 26th century BC. This assortment of rocks was used as a calendar. And so if you stand at different key places within Stonehenge and you look out over some certain key rocks, it shows you things. It can be used based on where the sun is on particular days. It could be used as a calendar. And here's a picture of Stonehenge with some tourists, give you an idea of the size of it. Now, for example, what I mean by used as a calendar, in the center is a key rock called the altar stone. And if you stand right there at the altar stone and you look at the sunrise, so at the sunrise, the sun is way off in the distance. And on some days, depending on what day of the year it is in the summertime, let's say this is the summer right here, the summer solstice, the sunlight, when it rises, it goes right through between these two stones and you can see the sun. Now, after the summer solstice, the sun is rising more to the south, so maybe way over here off the screen. And so they know it's not the summer solstice, but as summer approaches, the sun would approach, and then the sun rises. And then for a few days, the sunrise would be hidden by the rock on the right. But then on the day of the summer solstice, it would shine right through between those, and they would know it's the summer solstice. And that would be like, it would be analogous to us marking January 1st on our calendar. They would know this is the beginning of their year. And it would repeat every year. So as the year went on, the sun would go more to the south on sunrise, and then back here a year later, and they would know it's the summer solstice. Here is another picture, another angle at Stonehenge. Now, this one here, I believe this is sunset. So standing at the altar stone, looking off in the distance at another stone, a heel stone, on one of the days, and I don't know for this particular picture, I can't remember whether it's marking a solstice or maybe an equinox, but it's one of those 4 days. The sunset is directly over that rock. And so again, it could be used to set the calendar. In Wyoming, there is on the ground a medicine wheel, and this is an assortment of over the dark dirt, many light colored rocks, and they're arranged in a wheel. And notice these different piles of rocks, these circles. There's one that's very significant, it's in the middle. And then these other piles, notice that some are bigger than the others. I want to now look at a diagram of this to show you what one archaeologist made of this. But before I do, here's another angle, more the angle of what you would see if you were standing there. So you notice if you're standing on one of the piles, you look down a spoke, and on this particular day, you look down the spoke of the wheel right at the center, and you can see the sun either rising or setting. I'm not sure on this picture. So an archaeologist, Dr. Eddy was his name, he drew this diagram. And so it's interesting, archaeologists come across something like this, and their job is to ascertain, is this something that was naturally made? Is it a natural occurrence? Or is it something that an intelligence, that a human intelligence made? And what shows evidence that somebody actually made it is, does it have some order to it that has some benefit? And Dr. Eddy showed that there is an astronomical, a calendar benefit to this. And so let me take you through this right now. Here's the medicine wheel. There is something significant, as I said, about the center pile. And here it is. If you stand on this one pile that he labeled as E, it's a significant pile in that it's offset from the rest of the wheel, and you look directly over in line with the center of the wheel. This is the direction that you'll see the summer solstice as the sun rises. So it's kind of like with Stonehenge, that direct line marks the summer solstice when you see the sunrise. So it's a way of setting the calendar. But there's more to it than that. If it were just left to that, we could have just done with 2 piles. But let's look at other things. If you stand on this next pile, one of the bigger piles, then on the summer solstice, you look over one pile And that's where a bright star known as Aldebaran rises in the sky. You look over another pile, that's where Rigel rises. These are all very bright stars in the sky. Look over the center pile, and that's where Sirius rises. Sirius is the brightest star in our night sky. You can also, look over this D pile, and that's where another bright star, Fomalhaut, rises. And if you stand at this pile labeled C, and you look over the center, then this is where the summer solstice sunset is. So very significant astronomical things that all point to and tell you exactly when the summer solstice is. And just like with Stonehenge, it's a way of resetting the calendar. It's a way of knowing this is when the year begins. There's a place in New Mexico known as Fajada Butte, and this is it in the picture. And in a map of New Mexico, there it is where the red dot is on the upper left-hand corner, so in northwest New Mexico. And in Fajada Butte, there is a cave, and the cave opening is blocked by several large boulders. So the sunlight can shoot between the boulders and land on the back wall of the cave. So you're looking at part of the back wall of the cave. And as the sun moves from north to south through the course of the year, the sunlight creeping between two boulders falls. This is called the sun dagger right here. It falls somewhere on the cave wall. But on the day of the summer solstice, it pierces this spiral. So somebody in ancient times carved this great spiral as a way of marking where the sun dagger is on the day of the summer solstice. Now, gradually, as the year goes on, after the summer solstice, the sun moves more to the south, and so its shadow moves over. And this is on an equinox. The sun dagger no longer goes through the big spiral, but it goes through a smaller spiral. So somebody came along, maybe it was the same person, we don't know, but somebody made a smaller spiral to mark on the day of the equinox where the sun dagger goes. During the winter solstice, the sun goes through, the sunlight goes between two different openings in the boulders. And so if we think about how big did they know to make the spiral, when did they stop? Because they made it pretty big. Well, they stopped when it got to the limits where the sun daggers get during the winter solstice. And now I want to tell you about astronomy in ancient Greece. Most of astronomy that we do around the world is based on the foundations that the ancient Greeks set up. And so let's look at what they contributed. There was a writer, his name was Anaximander, and he was born in the 7th century BC, did his work in the 6th century BC. And he had a model of the universe he wrote about where the Earth is a cylinder. So there was this recognition of some roundness of the Earth even back then, and that it was at the center of the universe. So that's the idea of the geocentric model of the universe. And the stars were way off in the distance, including the sun, and there was a rim of fire going around it. So we don't have much on that, but this at least is a very early writing about a model of the universe with the Earth at the center. Let's fast forward a few centuries. So here we are a few centuries later. Plato was a philosopher, lived from 428 to 348 BC, and he had this idea of the Earth being at the center of the universe. It wasn't original to him. Of course, Anaximander wrote about it several centuries before, but certainly he along with everyone else, believed in the Earth being the center. And he, as a philosopher, not an astronomer, but a philosopher, he had ideas that he wrote about the perfection of things in the heavens, probably relating them to deities, the planets, the stars, and everything that's up there. And also this idea of perfection in geometry. And it was that circles are perfect shapes, spheres are perfect shapes, something beautiful, something perfect about them. And so he figured that the things up in the heavens must be circular, they must be spherical. The paths that they take as they go around the earth must be circular as well. And Plato had a student, very famous student, Aristotle, who lived from 384 to 322 BC. And Aristotle put this together, a lot of ideas that he learned from Plato, and he put together this model of the universe that was, well, it's like what you see in this picture here. So if you look at it, there is the earth at the center, and then surrounding the earth is water, so that thin layer of water. And that's pretty accurate. That's pretty much what our planet is. It is rock surrounded mostly by water. There are parts, the places where we live, called continents and islands, where the land juts out of the water. But for the most part, we've got a sphere of rock, of earth that is covered with water. And it was covered by air. Well, that makes sense. And then covered by a rim of fire, which sounds a little weird, but that's what he believed it to be. And these are the four elements that he thought of, that there was earth, water, air, and fire. And he believed that everything in the universe was made of some combination of those four elements. Now, beyond the rim of fire is the moon, Mercury, Venus, the sun, Mars, Jupiter, and Saturn. Now notice, these are the seven wanderers in the sky. And beyond them is the firmament of stars that he recognized are very far away. Now, this looks weird to us as 21st century viewers because we see that it's got a lot wrong with it. We know that the Earth is not the center of the universe. We now know that things don't move around the Earth. Well, the moon does, but the planets and sun and the stars, they don't move around the Earth. But we've only known those things for a little over 400 years. And so for most of time that people have been around pondering these things, they've believed that the Earth was at the center. So Aristotle's model, as you see it right here, was in force with some modifications that I'll talk about. But basically, from the time he came up with it in the 4th century BC to about the 17th century AD. So over 2,000 years, this was the model that was believed. And instead of focusing on what is wrong about it, I want to impress upon you what is right about it. And so we think about, as you look at the wanderers, the moon, Mercury, Venus, the sun, Mars, Jupiter, and Saturn, I want you to see that he got the order somewhat right. He recognized that the moon is, of those seven wanderers, the closest to us. Look at the order of the planets: Mercury, Venus, Mars, Jupiter, Saturn. That is the correct order of the planets moving out from the sun. Also, notice where he placed the sun. He placed it between Mercury, Venus, and Mars, Jupiter, Saturn. Now, at first glance, we can think the sun isn't between Venus and Mars. But if you think about it, going off of observing from Earth's perspective, and we think about why did he think the sun was between Venus and Mars? Well, there is something regarding the sun that does indeed separate Mercury, Venus, and Mars, Jupiter, Saturn. And it's that Mercury and Venus are the planets that are on the inside of Earth's orbit around the sun. Mars, Jupiter, and Saturn are the planets that are on the outside of Earth's orbit around the sun. So something about our differing motions around the sun, even though he didn't realize we were moving around the sun, but he did realize that there was something that set Mercury and Venus apart from Mars, Jupiter, and Saturn. Now, I want to talk about the four elements. Aristotle believed there were these four elements. And we now know of over 118 elements that things are made of, things like hydrogen, helium, carbon, oxygen. But he believed that everything was made of these four elements. And in fact, this was how he explained what we now know of as gravity. Sometimes things fall down, we call it gravity. Sometimes things go up, sometimes things float. And he related it to the elements that they were made of. So if you pick up a rock and you hold it in the air, so if you look at the picture, he said that there's earth, and then above it water, then above it air, then above it fire. So if you pick up a rock from the earth and hold it in the air and you let go of it, it falls back down to the earth. So Aristotle's explanation was it goes home. It is made mostly of rock, and so it goes to its home, to the earth. If you pick up some water in a cup above the earth, you hold it in the air, and you let go of the water, you dump the cup, it falls down because it falls down to the water. Well, so far all I've explained is things going down, but sometimes things go up. For example, if you are under the water and you release some bubbles, you blow out, the bubbles go up because the bubbles are made of air, and Aristotle's explanation for them going up is that they go home. The air is above the water, so they go up. Also, when you light a fire, the flames that are in the air seem to go upward, as if they're going home, up to the fire. So that was Aristotle's explanation. He believed in the four elements, earth, water, air, fire. And we now have the periodic table of elements, and we are every few years discovering more and more elements. This periodic table here goes up to 118. And in chapter 4 and 5, we will look more intently at these elements. After a few hundred years of Aristotle's model being believed, it was realized that there were discrepancies with Aristotle's model and things that the planets were doing in the sky that could not be explained by Aristotle's model. And so Claudius Ptolemy came along. He lived between AD 100 and 170, and he came up with what is known as the Ptolemaic model of the universe. What you're looking at here is actually a lithograph of Aristotle's model. I just think it's a neat picture. There's the Earth at the center. Here are the Latin names for the wanderers. So instead of the Moon, Mercury, Venus, you have Lunae, Mercury, Veneris, Solis, Martis, Jovis, and Saturni. And then various descriptions of stars and constellations going around the rim. But let's look at Claudius Ptolemy's model. One thing that was troublesome to Aristotle's model was it didn't explain what's called retrograde motion of the planets. If you go out night after night, week after week, and you watch the same planet at the same time every night, most often that planet, again, the same time every night, it'll creep slowly to the west every night. And so you go out the next night at the same time, it's just a little more to the west than it was the previous day. And you go out a month later and it's much more to the west, but it slowly creeps to the west. However, there are some times when a planet does the opposite. It slowly creeps to the east. And so this is a time-lapse photo, many nights of some planet that was going to the west night after night, and then it did this what's called retrograde motion, this backwards motion, and then it resumed going like that. And according to Aristotle's model, where the planets move around in circles, there was no explanation for why the planets would go backwards, and then resume their course. So Claudius Ptolemy, he came up with a solution. He stuck with Aristotle's model, but he added to it. Now, before I get to Ptolemy's solution, I'll show you what's really going on. what you see in this animation here. The inner planet is Earth. We're going around the sun, and here's an outer planet. Let's call it Mars. And so the line between them is the straight line distance. Now, as Earth and Mars are going around the sun, Mars is going slower. There are times that relative to the background stars that are way off in the background to the right, there are times that Mars looks like it's going one way, then backwards, then another way. So that backwards bit is the retrograde motion. And you can get the same effect if you have two runners running around a track. One is faster than the other. Then as they look at each other, relative to the background, there's times when one will seem to be moving more to the north and times more to the south. And this is, again, an effect of when you have two objects, one of them being an observer, going around something else at different speeds. Well, that's what we know now that the reason for retrograde motion is. Let's look at what Ptolemy's solution was. Ptolemy said that while Aristotle's model is basically true, the planets, including the sun and the moon, moving around the Earth, he said that the planets move on what's called epicycles. So they are these little cycles that are on top of the big cycle. In Ptolemy's model, the planet goes around the small circle called the epicycle, while the small circle goes around the big one, and the result is the planet follows the dashed path. So the planet does a bit of a spiral. So right here is the retrograde loop where it appears to go backwards. Science, and particularly astronomy, for a couple of thousand years did not advance much further than that until the Renaissance, until new things started to occur in the 15th century and things really start to boom in the 16th century. But until that time, astronomy didn't advance that much because it was based on some fundamental errors. And it was these two main errors. One is the belief that the Earth is the center of the universe. That was something that was just treated as fact. Everybody knew the Earth is the center of the universe. And much of science, particularly astronomy, was based on that fact. And until people were willing to abandon that idea, astronomy wasn't going to advance much more. So that was the first error in Greek astronomy, the notion that the Earth is the center of the universe. The second error was belief that the heavenly bodies operate on circles and spheres. Remember, I said going back to Plato that a circle or sphere is a philosophically perfect shape. And so that led to them not being able to accurately predict the motions of the planets because they assumed that they all moved on spheres, because they assumed that the things in the heavens must be heavenly bodies, there must be some divinity associated with them, so they must be perfect. And so it wasn't until the Renaissance in Europe that scientists started to get past these errors in Greek philosophy and help astronomy to advance further. I want to make a note of one fellow in ancient Greek, Aristarchus. I just a minute ago said that nobody was willing, or hardly anybody was willing to abandon the idea that the Earth is at the center of the universe. Well, there was one fellow, he was about a century after Aristotle's time. Aristarchus did write about a heliocentric model of the universe, that the sun is at the center. And this is more accurate. While we now know the sun isn't the center of the universe, it's the center of the solar system, but it's better than a geocentric model. So Aristarchus wrote about the sun being at the center, the planets move around the sun, as you can see in the picture, and the moon moving around the Earth. And the reason that there is day and night is that the Earth is rotating once per day. Now, I don't know if Aristarchus actually believed this to be true. Very often philosophers and scientists will write a hypothesis and they won't necessarily believe it, but it's just writing a hypothesis that's worth investigating. So whether or not he believed it, I don't know, but he did write about it. However, his work seemed so absurd at the time that the sun is at the center of the Earth's and the planet's motion that he was completely ignored. And it wasn't until Nicholas Copernicus came along in the 16th century and read his works that things started to change. So, what have we learned? Why does modern science trace its roots to the Greeks? The Greeks developed models of nature and emphasized that the predictions of models should agree with observations. So, you think back to why did Aristotle come up with that model? Well, it was based on observations of what he saw, the planets going around. He thought they went around the Earth, but it was still based on what he observed. Um, Ptolemy came up with the idea of epicycles, planets going around in those small circles, because it better fit observations of retrograde motion. How did the Greeks explain planetary motion? The Ptolemaic model had each planet move on a small circle whose center moves around Earth on a larger circle. One more ancient Greek fellow I want to talk about. His name was Eratosthenes. And every now and then I hear people talking about a flat Earth. Is the Earth flat? I remember learning in elementary school that Christopher Columbus discovered that the Earth was round, and he, of course, did his voyage in 1492. And that is not correct. They knew centuries, actually millennia before Christopher Columbus sailed the ocean blue in 1492, they already knew that the Earth was round. In fact, Columbus would not have made the voyage that he did. He went west going for India, and he would have never made that voyage if he didn't know that the Earth was round. And in fact, it was around the year 240 BC that Eratosthenes not only believed that the Earth was round, but he used geometry to very accurately calculate the circumference of the Earth. So what he did, he was in two different locations, and he looked at the direction that the sunlight made in this one city, the direction of the sunlight, the angle that it made with the ground in another city, and he was able to calculate the curvature of the Earth between those two cities, and with the distance was able to calculate the circumference around the Earth. He did it with great precision. In fact, he calculated the circumference of the Earth to be 42,000 kilometers. Earth's true circumference, we now know, is 40,000 kilometers, so he was only off by about 5%. Very good for ancient Greece. And that is the end of our study of ancient astronomy. Have a great day.